Yeah, I can hear you good.
All right. All right, I have us going through question 12 on test 1 last time. So let's go to question 13. So what is the total measurement in degrees of the entire circle? If we were to go 360. Right. This is how much of that? If there's 5 sectors. In other words, there's a total of 12 sectors that they've broken the unit circle up into. And then they're asking us what is the degree of 5 of those sectors. Well, what's the degree of each sector? If it's evenly divided into 12 sectors, how much is each sector?
30.
So each of those is 30. How much are 5 of them?
150.
Correct. Okay. Now, this is a great example of a question where they give you information that's completely irrelevant. Notice this 46 pi never came into play.
Yep.
So that's a good lesson to learn, is that not all information that they give you is relevant to the question, and you have to know that you don't care about the 46 pi.
Okay.
All right. Can you read that okay?
Yeah.
All right. Go ahead and read that paragraph.
Every day is 7 days.
So tell me how you're going to solve it. Do you have your calculator handy?
Yeah.
Okay.
So
well, first, before you go to your calculator, just tell me what you're going to do on it.
Add all the numbers together and then divide by 5.
Perfect. That's all you need to do. Again, notice that 730 had nothing to do with anything. So all you need to do is add those 5 numbers together, divide by 5. What do you get? Let's have you do that on your calculator just for practice.
I got G.
Good. That's the right answer. Okay, on 15, so which of those equations has the solutions x equal minus 3 and x equals 6? Which one?
A.
Good. If you get them correct, I'm liable not to say anything, and we'll just go on.
Okay.
Because it's clear that you understand how to do that. What they're basically asking you to do is get rid of the parentheses. What do you have left? In other words, if you remember PEMDAS, parentheses, exponential, multiplication, division, and stuff like that, well, they're asking you to simplify that. The only thing there is in that is parentheses. So let's get rid of the parentheses. How do we do that?
Negative 2x plus 20.
And what does that equal? Simplify it.
Negative 2x plus 27.
Beautiful. H. All right. 60% of x equals 90, then what is x?
$150.
Good. Did you do that algebraically?
Huh?
Did you do that like this?
Yeah.
Okay, that's great. You could have also back solved it, notice. In other words, we know that x has to be greater than 90, so there's only two choices, 150 and 1500. If we take 60% of 150, we get 90. So even if you didn't know how to set up the algebraic equation, it really would have been quite easy to get the answer. All right. It's a little tougher problem. There's two ways to do this problem. This is a classic problem of two variables and two equations. And you can do it that way. As long as you know how to solve two variables and two equations, you'll come up with the answer. It's also a pretty classic problem of back solving. Can we solve this problem by starting with one of the answers and seeing if it's right, and if it isn't, go to a different one?
Is the right answer 185?
I think it is. How'd you do it?
I started with 835 and subtracted 510, and I got 325, and then I subtracted the 325 from the 510 and got 185.
Interesting. Okay, well, let's see if 185 is correct.
All right.
So the cost of a drink is $1.85. What's that make the cost of popcorn from the first sentence?
$3.25.
So now the cost of two popcorns would be $6.50 plus $1.85. That's equal to $8.35. So yes. In other words, if you weren't sure if $1.85 was the right answer, you could have tested it. And that's the key to back solving. Back solving is something that has nothing to do with demonstrating how much math you know or anything else. Back solving is strictly when you want to get the answer right. And that's the goal here. The goal here is not to prove to anybody that you know the math or anything. The goal is to get the answer right. So however you do it is fine. And there's nothing wrong with back solving. In other words, if it's difficult to come up with the two equations and solve them, then don't do it that way if you have another way to do it. Okay. And whatever way you did it, I know you explained it to me, and I'm not certain it was valid, but the fact of the matter is that you came up with $1.85. The next step is to test that and make sure that it's correct. Okay. And you can do that by merely figuring out what the price of a box of popcorn has to be if the drink is $1.85. So there's a lot of good stuff to learn from question 18. It's not just about plowing into the algebra and solving it. It's very much about, well, let's pick one of the answers and see what happens. And the beauty of back solving this problem is that if $1.85 was not correct, we would probably know whether we needed a smaller price or a bigger price. And that's extremely useful information. When you have a problem where if you back solve it, you're going to know which direction to go, then you almost certainly want to try to back solve it. That's the way to solve the problem. Because at most you will have to try two numbers. You'll have to try $1.85, and if that doesn't work, you'll have to try $2.55, and if that doesn't work, you'll know the answer or one of those will work. So back solving is a hugely valuable method to use to do well on these tests. Now this is a bit of a tricky problem. This is not a hard problem, 19. You just have to be very careful and read it carefully. The fact that it is 6 lines long does not make it hard. And remember that. Just because it's a lot of words doesn't make it a hard problem. So what do the 2 lamps cost?
$8.99.
Well, $8.99 per lamp. What do 2 of them cost?
$17.98.
Okay. Then we have a 7% tax. So what's the total charge?
Well, you got $1.25.
That's the tax. So what do you have to do to that to get the total charge?
Add it to the...
Okay. Do that. What do you come up with?
$19.23.
All right. Now, everything you've done so far is correct, but be very careful about reading the last 2 sentences. What is the answer?
D.
No, that would be the answer if you gave him a $20 bill. Notice that's not what it says. You have 20 $1 bills. How much would you need in coins if you wanted to give him the exact change? Well, the total bill is $19.23, right?
Yeah.
So how much exact change would you have to have if you were to pay the total bill? 23 cents. Right? You'd give him 19 $1 bills and 23 cents. Now, notice that the only answer on there is 24 cents. That's because we have a round-off error. When you multiplied by 7%, you rounded it off, and we only ended up with a price of $19.23. In actuality, that should have been rounded up to be $19.24. Doesn't really matter because they don't put 23 and 24 on there. They put 24 only. So we would need 24 cents in exact change to pay this bill. We'd give him 19 $1 bills and 24 cents in change. I guarantee you that 3/4 of the students taking this test will answer D, because they'll read these last two sentences too quickly. You can scan those last two sentences and interpret that to mean you give them a $20 bill, how much change does he give you? And that's not what it says. You see the difference? All right. And they definitely put the trap answer on there. The trap answer is 76 cents. If they wanted to be a little kinder, they would not have put that answer on there. And then when you got 76 cents or 77 cents, you would say, I must have made a mistake, and go back and reanalyze the problem. But boy, when they put the trap answer on there, it's hard to avoid it. You just have to really, really pay attention to detail. So we have r cubed equals 343. What is 3r equal to? Well, first, what's r equal to?
$114.
Did you take the cube root of 343? Correct. What's 3r equal to?
41.
Good. All right, so let's talk about your calculator. The first time through, you probably hit the square root of r to get whatever number you got. Whereas what you really need to do is hit 343 raised to the 1/3 power. That's how you take the cube root. Or 343 raised to the 0.333 power. Same thing. You might have some round off error that gives you a number other than exactly 7, but you should be able to figure out that 7 is the right answer. 7 times 7 times 7 equals 343. Okay?
Yeah.
All right. Rank those three numbers in the least to greatest. First of all, how are we going to do that?
We gotta change them from fractions to decimals.
Okay, what's pi?
3.14.
What's 7/3?
1 1/3. So
No, it's actually, it's 2 1/3. It won't matter for this problem.
2.33.
And 9 halves?
4.
Doesn't even matter what the rest of it is.
Yeah.
In other words, they give you enough differentiation between these three answers that is all you need is the first digit on any of them to rank them. So you don't even have to be exact. Even if you didn't know that pi was 3.14, as long as you knew that it was 3 and change, and this was 2 and change, and this was 4 and change, you could rank them properly. Yeah. Mm-hmm. Yeah, this is kind of an interesting problem. Okay, this demonstrates another example of a problem that you can solve algebraically, or you can back solve it. And I just can't highly recommend enough this back solving, because most people have a difficult time setting up the algebra properly. How would you back solve this? Pick one of the answers and see if it works. That's the way you back solve it. In other words, you basically pick all of the answers and try it. In other words, does 9 minus 3 and 13 minus 3, does that equal to 3/4? And it does not. What's the next one you would try?
+3.
You tried that because it was the easiest arithmetic, right?
Yeah.
In other words, you didn't try 1 1/4, negative 1 1/4, and you didn't try 1 1/2 because that would have been really hard arithmetic, and you're absolutely right. That equals 12 over 16, which equals 3/4. And that is a good method to use when you're back solving something. In other words, you want to use something that makes the math easy if you can. Now, if I wanted to solve this algebraically, I would say, okay, let x be the number so that 9 plus x over 13 plus x equals 3/4. Now, this is a fairly simple problem to solve. 36 plus 4x by cross multiplying, x equals 3. So we could do it algebraically, but most people have a much harder time setting this up algebraically than they do by back solving it. So I'm a huge fan of back solving. I think that whenever the problem can be back solved, you should back solve it. Pretty much. What's the slope between these 2 points? This is something you absolutely have to know. There's probably 5 or 6 questions that involve slope. First of all, what's the word definition of slope? Starts with an R in the numerator and R in the denominator.
Rise over run.
All right. That's what you want to remember for the rest of your life. Forget about the y2 minus y1 all over x2 minus x1. If you can remember rise over run, you'll always be able to figure it out. The rise is the change in y. The run is the change in x. Well, the change in y is y sub 2 minus y sub 1. The change in x is x sub 2 minus x sub 1. So let's do that math. Here's x sub 1, here's y sub 1, here's x sub 2, here's y sub 2. So plug in and solve. So what is y sub 2 minus y sub 1?
-3.
Well, negative 7 minus 4, right?
Yeah, minus.
Okay. What's the run?
2 minus 5.
All right. What is that numerator?
-11 over -3.
So, what is the answer?
E.
Yeah. In other words, negative 11 over negative 3 needs to be simplified. Negative over negative becomes positive, so you have 11/3. Okay? Now, one thing to remember. You don't have to necessarily do y sub 2 minus y sub 1. You can switch it up if you want. In other words, y sub 1 minus y sub 2 works as long as you switch it up in the denominator also. And that might be a little easier to get a handle on. In this case, it would have been. Because 4 minus a minus 7 gives you 11, and 5 minus 2 gives you 3. You get the answer directly. So when I figure up slope, I prefer to work with positive numbers rather than negative numbers. So knowing that, I'm going to take y sub 1 minus y sub 2, that's a positive number. And x sub 1 minus x sub 2 is a positive number. I'm going to do it that way. I'm not going to do it y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You can go either way, just don't mix it up. In other words, what you can't do is y sub 1 minus y sub 2 all over x sub 2 minus x sub 1. That'll give you the negative of your proper slope.
Okay.
Prime numbers. They're hardest questions, but not really if you know how to find the prime factors. Give me the prime factors of 38. Use the tree method. What are factors of 38? If you don't know how to factor something, always start by splitting it in two if you can.
19 and 2.
Are both of those prime?
Yeah.
So that's the greatest prime of 38. Now let's do the same thing with 100. Split it.
50 and 2.
Okay, 2 is prime, but 50 is not.
25.
Well, again, 2 is prime, but 25 is not.
5.
What's the greatest prime factor of 100?
5.
What's the sum of the greatest prime factor of the first one plus the greatest prime factor of the second one?
24.
Yeah. It's actually a pretty easy problem. Alright, this one's a little tricky. You have to know what to do as an opening step. They want to know what t squared plus v squared equals. First of all, you realize that that right there does not equal t squared plus v squared? This part right here? What does that equal? Foil it. Take t plus v, multiply it by t plus v. What do you get?
T squared plus v squared.
You do not. Let's foil it. If you got that, this wouldn't be much of a problem, would it?
No.
So you're pretty sure that that's not what you get. So foil that. Multiply that by that using the FOIL method. What do you get?
T squared plus TV plus VT plus V squared.
Simplify that. What's that equal to?
2 TV.
Okay, so when we square t plus v, we don't get t squared plus v squared. We get t squared plus 2tv plus v squared. So they've told us that t squared plus 2tv plus v squared is equal to 289. And they've asked us what t squared plus v squared is. Well, if we only knew what tv was, we'd have... They've told us what tv is. tv is 30. So now what can I do? Remember, they're looking for t squared plus v squared equals what?
229 then.
E. All right. That's a good question, and it merely highlights this principle. When you have a binomial and you square it, you get this every time. Notice that that's what we got when we squared t plus v. We got t squared plus 2tv plus b squared, or v squared. Okay, the other one that's huge, that you'll sometimes, actually frequently have to do, is this one. Notice the difference. There's not much. The only difference is the sign on the middle term is negative as opposed to positive. The first term's the same, the last term's the same. So it's worth memorizing these two. By memorizing it, I mean that the next time you have to do a t plus v squared, you won't have to FOIL it. You'll know immediately that it's one of these two. For example, what is 3x plus 2y squared? So the first term is that squared. What is that?
9x.
What's the middle term? The middle term has to be 2ab.
2xy.
Well, it would be 2 times this times that. Well, that's 6xy times 2. That would be 12xy. And what's the last term? That squared?
4y.
4y squared. In other words, the advantage of memorizing this is that it allows you to apply it to any binomial that's squared, even if it's a complicated binomial like 3x plus 2y. If I know that a plus b squared equals what it does, then I can do this very quickly without having to resort to FOIL. And it's going to save you about 30 seconds. And that's a lot. If you can save 30 seconds on a problem on the ACT, you've accomplished a lot. That's 30 seconds that could be spent on harder problems. So it's worth memorizing that just because it comes up so often. And on problems like this, if we didn't know, if we didn't have that memorized, it might not be so easy to recognize how to solve that. And we might be inclined to try something like this. Well, if that's equal to 289, why don't I take the square root of both sides? Well, okay. What's the square root of 289? That's got to be, I don't know. Do you have your calculator? What's the square root of 289?
$17.
Okay. If this was my first step, I'm getting nowhere. Knowing that that equals 17 does not help solve this problem. In other words, I can go off on a branch that's completely counterproductive. And the one thing that keeps me from doing this step is knowing that when I expand that, I get t squared plus 2tv plus v squared. I don't have to FOIL it. I know that's what I'm going to get every time. And if that's equal to 289 and I see what they told me TV is equal to, then now it's a piece of cake. So this principle, I can't overemphasize how important it is to remember that what a squared plus, or a plus b quantity squared is.
Okay.
What's the left side equal to? What do you do to the exponents? You multiply them, right?
12a plus 20.
If that's equal to x to the 44th, what can I now say is true? I have the same base to one exponent equals the same base to a different exponent. What has to be true about the exponents? They have to be equal.
Yeah.
12a plus 20 has to equal 44. So now solve for a.
Two.
Good. Now, 27 is a log problem, but it really isn't a log problem. Have you had logs at all yet, Jared?
Yeah.
Okay, if you've had logs, What is the exponential expression of that statement? Because that's what we need to do to solve this. We need to know how to express it exponentially.
2.
Remember that logs are exponents. So whatever we do, that 2 has to be the exponent.
16.
It's x to the 2 equals 16. Now notice what I did. I took the value on the far left, I raised it to the exponent on the far right, and it's equal to the argument of the log. That's all you have to remember. To convert log expressions to exponential expressions, just remember that. It's the far left raised to the power of the far right equals the number in between. So what's the solution to this? If x squared equals 16, what is x? Good. All right, questions like this, it can be useful to draw a picture just to see what they're talking about. Okay, so they're saying one point is minus 2 comma 9. I'll make that point minus 2 comma 9. It's not terribly important to draw it to scale. Doesn't really matter whether that's 2 units and 9 units. I've got it in the right quadrant. It's in the second quadrant. And then they're telling us that the midpoint of the line is at 4 comma 4. Well, I'm going to call that point 4 comma 4. That's in the right quadrant. We have a line, and they want to know this point right there, x comma y. Knowing that 4 comma 4 is the halfway point between minus 2 comma 9 and whatever this point is here. Well, this is as easy as it looks. In other words, the method that you would intuitively use is the right one. Let's look at the x-coordinates. This x-coordinate is how far away from that x-coordinate? Okay, so how far away should this x-coordinate be from this x-coordinate?
6.
So what is it?
10.
Now let's look at the y's. How far away is 4 from 9?
5.
So what should y be?
-1.
Beautiful. J. All right, they're going to hit us with some conics and trig in the next 2 questions. In order to do 29, you have to know the general formula of a circle.
Okay.
You remember what it is?
Pi r squared.
Well, that's the area of a circle. This is actually the general formula of a circle, where h and k are the center and r is the radius. In other words, if I had a circle with radius 2 at the origin, then it would just be x squared plus y squared equals 4. In other words, h and k would be 0, the radius would be 2, and I would get that. If the circle is not at the origin, let's say it's over here, then whatever the coordinates of that circle are, that's the h and k. And r is still that. Okay? So knowing that, what is the radius of this circle? Notice that it fits this format really well. X minus h squared plus y minus k squared equals r squared. What is r?
-4, -1.
R is the only thing you need. They didn't ask about the center. The center would be at 4, 1. That's the center of the circle. But the radius of the circle is what? Look at the answers.
7, 14 squared, 17 squared, 14.
According to this formula, r squared is what? Right?
Yeah.
So what's r?
7.
Is the square root of 14 7? 7 times 7 is 49.
Square root 14.
There you go. That's the radius. All right, a little trig. We haven't done a lot of trig, but there are precisely 4 questions on this exam that are all trig. So it's not hard trig, it's easy trig. It's trig 101. In fact, it's the first week of trig. That's it. So it's really a gift that they're going to put 4 trig questions on here, and you should be able to get all 4 of them. But you have to know the minimal amount of trig. You don't have to know a lot of trig, but you got to know the minimal amount. So what they want to know here is what the cosine of this angle is. Well, what's the cosine of A equal to in terms of the sides?
Well,
SOHCAHTOA. What does the ka mean? What does that mean?
adjacent over hypotenuse.
Correct. Well, they haven't given us the hypotenuse. So first thing we have to figure out is the hypotenuse before we can take the adjacent and put it over the hypotenuse. What's the hypotenuse here? It's a right triangle. So what is Z? Apply the Pythagorean theorem.
124 plus 25 equals 8.
What is Z? Square root of 169, right?
Yeah.
That's 13. So now, what is the cosine of angle A?
13.
Adjacent over hypotenuse.
5 over 13.
Okay, 5 is not the adjacent. 5 is the opposite.
12 over 13.
There you go. 12/13. Now, this happens to be a special triangle in that if you start with right triangles and try to figure out what the minimum perfect Pythagorean triangles are, there's one of them. That's the smallest one. There's none smaller than that. And the next one is 5, 12, 13, believe it or not. In other words, there's nothing in between these. So both of these are worth memorizing, so you don't have to perform the Pythagorean theorem to solve them. In other words, if you recognize that this was a 5, 12, 13, you would have known that it was 13 without doing the math. Just like if you see a 3, 4, 5, if you see a 3 and a 4 and they're the short sides of a right triangle, you know this is 5. You do not have to use the Pythagorean theorem. If it's a 3, 4, 5, it's a right triangle. If it's a 5, 12, 13, it's a right triangle. These two are the ones you want to memorize because you're going to see them a lot. And every time you see them, you'll either have to use the Pythagorean theorem to solve them, or you'll be able to recognize them and you'll immediately be able to complete them. And I'm telling you, you'll save 30 seconds by being able to recognize that that has to be 13. The other clue is to look at all the answers. Look at how many 13s there are in this thing. So if you look at these answers, it would be fairly easy to assume this side had to be 13, and then you'd say, oh yeah, that's a 5, 12, 13 triangle. So now I just have to figure out what the adjacent is over the hypotenuse. Yeah. All right. 31 is very easy. And I say that because sometimes these problems can look a lot harder than they are. This one is easy because all we have to do is know our rules for exponents. We have to know how to multiply numbers with exponents, and we have to know how to divide numbers with exponents. Always go term by term. In other words, the first thing we're going to work with is the number part. Then we're going to work with the A, and then we're going to work with the B. So let's do the number first. What is 13 times minus 8 divided by 4?
Negative 26.
Minus 26. Well, that's quite helpful. That means A is not right. B could be right. C can't be right because this minus 26 is in the numerator. So already we've eliminated it between B, D, and E. Okay? So that's helpful. Now let's do the letter A. What's the numerator of the A's? What's A to the second times A to the third?
Is 6.
Fifth. We're going to add them. Remember, we're multiplying the bases. If we're multiplying the bases, we're never going to multiply the exponents. They don't go together. You always do one level less on the exponents. So if we're multiplying the A's, we're going to add the exponents. If we're dividing the A's, what are we going to do to the exponents? So our net A is A to the third. Well, does that help narrow our answer down? Well, B still works. D does not, nor does E. We're done. We got the answer. It's B. Has to be. merely after solving for the number and the A part, that's all we needed. We didn't even need to do the B part. The B part would be b to the 4th times b to the 5th, so that would be b to the 9th divided by b to the 6th, so that would be b to the 3rd. So if we wanted to do it, we'd get b to the 3rd. But an awful lot of these questions on the ACT, they give you a head start where if you're doing it piece by piece, you know the answer before you even finish it. And this is a good example of that. All right, let's stop at 31. And I have to commend you for working this week. I don't have very many students that decided to do a session this week, so good on you.
Thanks.
And hopefully it'll help. When's your ACT test?
I think it's like exactly a month maybe.
Yeah. Okay. Well, I hope we have time for 3 or 4 more sessions. I think it'll help a lot. All right?
Okay.
All right, Jared. Talk to you later.
Thank you.
Bye-bye.
Bye.